a weighing machine and weigh 1.6 trillion iron atoms. Along with that, also measure 104.9 billion oxygen molecules. Can you find some flaws in my statement? Do these statements sound normal to you? Of course, these are incorrect statements. How can someone calculate the weight of atoms and molecules using a weighing machine? These are so small and tiny that even in a small substance, there will be such a vast number of these tiny atoms and molecules. Therefore, we need some magnitude or a unit to express their number. This takes us to the concept of mole and molar mass. Here, you will understand that we can use mole as a unit to count the entities at the microscopic level. Now, by entities, I mean atoms, molecules, electrons, particles, ions, etc. So, we can use mole to count these tiny entities just as we use dozen to measure 12 items and gross to measure 144 articles. So now we can say that the mole depicted using the symbol MOL, mole, is the SI unit of the amount of a substance. 1 mole is equal to 6.022 into 10 raised to 23 elementary entities. We have seen in the previous slide that the mole is the unit for expressing the amount of a substance. Now, what do we mean by the amount of a substance? The amount of a substance expressed by the symbol N is the measure of the number of entities that comprise the substance. Here, an important point needs to be mentioned that a single mole of a substance will always contain the same number of entities no matter what the substance is. Let us now use this concept to calculate the number of atoms that make up a mole. Let us consider if the mass of a carbon-12 atom is known to be 1.99 into 10 raised to the power 23 grams, and if we know the weight of 1 mole of carbon, that is 12 grams, then we can calculate the number of atoms that comprise 1 mole of carbon-12 number is equal to 12 gram per mole divided by 1.99 into 10 raised to the power 23, which is equal to 6.022 into 10 raised to the power 23 atoms per mole. You can see that this is exactly the same number that we studied in the previous slide, right? Now, we can infer from the above example the formula for calculating the number of atoms that comprise 1 mole of a substance is equal to the weight of 1 mole divided by the mass of the substance. You remember the fixed number which we just now saw in the previous slides. This number, which depicts number of entities in 1 mole, is known as Avogadro's constant or Avogadro's number, denoted by Na. Hence, we can say that 1 mole of hydrogen atom is equal to 6.022 into 10 to the power 23 atoms, or 1 mole of water molecule is equal to 6.022 into 10 to the power 23 molecules, or 1 mole of sodium chloride is equal to 6.022 into 10 raised to the power 23 formula units of sodium chloride. I am sure now you will be clear with the concept of the mole. Now, we can move to the definition of molar mass, which is the mass of 1 mole of a substance in grams. Hence, we can say that molar mass is equal to atomic or molecular or formula mass. The unit of molar mass is gram per mole. Now, let us try to calculate the molar mass of water and carbon dioxide. In case of water, we know that molar mass of 1 mole of hydrogen is 1 gram per mole and molar mass of 1 mole of oxygen is 16 gram per mole. In the chemical formula of water, there are 2 hydrogen atoms and 1 oxygen atom. Therefore, upon adding the masses, we get the molar mass of water, which is 18 gram per mole. Similarly, the molar mass of 1 mole of carbon is 12 gram per mole and molar mass of 1 mole of oxygen is 16 gram per mole. And in the chemical formula of carbon dioxide, there is 1 hydrogen atom and 2 oxygen atoms. Therefore, upon adding the masses, we get the molar mass of carbon dioxide, which is 44 gram per mole. As we are approaching the end of the class, I would like you to ponder over one question. Suppose I give a compound, for example, water. We already discussed that water contains oxygen and hydrogen. Now, how will you find out the ratios of the constituents of those compounds? Think over this question and we will discuss this in the upcoming video. Now, let us summarize what we have learnt.
Manorama Horizon. Learning made simple.